So in your next homework assignment, you're going to be working with L'Hopital's rule. But before we develop and use L'Hopital's rule, which is a rule that is designed to deal with indeterminate forms, and those are forms that are, say, 0 over 0, infinity over infinity, infinity over 0. There's a variety of different indeterminate forms that we'll be looking at in a little bit. First, we want to take and just have a quick conversation about the indeterminate form 0 over 0, and we want to get at why we need a technique for dealing with it. We want to determine that there's an issue with the indeterminate form 0 over 0. So here I have three limits, and you can remember from Calc 1 last semester you learned to find limits of some functions. In this particular case, each of these limits, if you were to try to plug 2 in, 1 you'll get a division by 0, which is undefined, so you can't plug 2 in. The other thing that you want to notice is that if you plug in 2 to the numerator and denominator, you wind up with the 0 over 0 form. 2 squared is 4, minus 4 is 0 over 2 minus 2 is 0. Here you get 2 minus 2 is 0. 2 squared minus 4 is 0. Here you get 2 minus 2 is 0. You get 2 squared is 4. 4 minus 8 is negative 4, and then negative 4 plus 4 is 0. So each of these three limits has the form 0 over 0. And what we want to identify is that although they have the same form, their limit is different. So for this one, if you remember the technique that we learned to deal with taking the limit as x goes to 2 of a ratio of two polynomials was we tried to factor. So the numerator factors as x minus 2 times x plus 2. We try to factor. And then if there are common factors, we cancel. So we recognize that x minus 2 divided by x minus 2 equals 1. As long as x isn't a 2, we can't plug 2 in. That causes a division by 0. So once we do that simplification, we get the limit as x goes to 2 of just x plus 2. And this, there's no restriction on the domain of x plus 2. The domain is all real numbers, so it's okay to plug 2 in. We get 2 plus 2, and we discover that the limit of this function as x goes to 2 is 4. This one, we get the limit, and you can see all we've done is flip the numerator and denominator over from the previous example. The limit as x goes to 2 for this one is going to be x minus 2 over, we have x squared minus 4, so we factor it just like we did in the previous example. Difference of squares, x minus 2 divided by x minus 2 is 1. We get the limit as x is going to 2 of 1 over x plus 2. And we're actually allowed to plug 2 into this because plugging 2 in doesn't cause a division by 0. So if we do that, we get 1 over 2 plus 2 is 1 over 4. No big surprise, we got the reciprocal of the previous result. But the form that they have if you plug 2 in is 0 over 0. So even though they have the same form, the limit that you get is different. Now this one, we have the limit as x goes to 2 of x minus 2 over, how does this guy factor? X minus 2 times x minus 2. So x minus 2 divided by x minus 2 equals 1 as long as x isn't 2. So we get the limit as x goes to 2 of 1 over x minus 2. And the idea here is as x goes to 2, x minus 2 goes to 0. And if the denominator goes to 0 and the numerator stays constant, then this will actually go to infinity. It becomes infinitely large. The limit is infinity, which means the limit does not exist because infinity isn't a number. So the idea here that we're trying to get at is even though each of these has the form 0 over 0, which means we actually can't plug 2 in because we get division by 0, which is undefined. but it does have the form. Each of these has the same form, but have completely different limits. And the conclusion that you can draw from this is 0 divided by 0 by itself is meaningless, because it can play out in many different ways. And L'Hopital's rule is going to be a rule that helps us to deal with this situation and find limits that would otherwise be difficult to access, to get at.